Okay, everybody. So, first of all, an introduction to fractions. I mean, you use them all the time. You're like, you're driving down the road and the needle. Okay, that's a terrible gas gauge. Let me try this again. There we go. And the needle is right there. And you're like, oh yeah, I'm down to 3/4 of a tank. Okay, yeah, cool. So, you're doing a fraction. So the circle is cut into 9 equal slices. What fraction of the circles are shaded? So there's 1, 2, 3. So 3 out of 9 are shaded. Okay. And let me just see what they do. Okay, yeah, 3 out of 9. And that can be simplified down to 1/3, but we're not there yet. Okay. If you're there already, that's great. But yeah, 3 out of 9. Let's do one more of those. I'm slow, but that's okay. All right. So what fraction of the circles are shaded? Looks like 1 out of 7. So 1/7 of them are shaded. So practice that a whole bunch. Okay, so now this time, each circle counts as one whole. Okay, so as a mixed mixed numbers are things like 3 1/4, 2 and 2 2/9, 5 and 6/8. Okay, those are mixed numbers. All right. So how would we represent the shaded region that way? So we've got 1, 2, 3 complete circles that are shaded, and half a circle, so 3.5. Okay. Or I could say I've got 1, 2, 3, 4, 5, 6, 7 halves are shaded. Well, it turns out 3.5 and 7 halves are the same thing. Okay. So, that's pretty cool. That's how it's done. All right, so on this one, write 11/7 as a mixed number. So here's what you do. You take the bottom, called the denominator, and divide it into the top. And you say, all right, 7 divides into 11 once. 1 times 7 is 7. We subtract, get a 4 for our remainder, and therefore 11/7 is going to be the same thing as the quotient, and then the remainder over the divisor or denominator. Okay, and that's how it goes. Let's do one more of them. Okay, so 13/5. So the bottom divides into the top twice, and 2 times 5 is 10. Subtract, get a remainder of 3. So 13/5 is the quotient, and then the remainder over the divisor. And that's it every time. All right, so now we're going to do the exact opposite process. So 4 and 1/5. So we're going to end up with an improper fraction, meaning like we started with on the last topic, a fraction where the numerator, the top, is bigger than the denominator. Okay. So, well, I don't know if you noticed on the last one, but the denominator doesn't change. So we know the denominator is going to be 5 for this one. All right, so then what? Well, then we would start at the denominator and say, all right, let's multiply there. 5 times 4, 20. Then we'll keep going and we will add. So our 20 plus our 1 is 21. So 21/5. Let's do one more. Okay, so 1 and 4/9. Well, the denominator is 9. That's just how it is. And then we do 9 times 1 is 9. And then we add on a 4. So 9 plus 4 is 13. That's how you do it every time.